Okay, so hello everyone. I got assigned to start, so let me start on time. My name is Daniel Meggert. People call me Danny. I work on Eclipse for more than 15 years now. I was one of the original committers in 2001 when Eclipse got open sourced. And since then, I've worked on almost all components in the SDK. I also contribute to eGit and other projects. So that's my history, and currently I'm the platform and the JDT lead, and I represent the top-level project in the Planning Council, and I'm also a member of the Eclipse PMC. And I'm working in Zurich at the IBM Rational Zurich Research Lab in IBM Research. So what are we going to do today together? So the first thing that we will look at are the new Java language features. So I say Java language features because we will really focus on the things that I think are interesting in Java 8 for you guys in the language. There are a lot of other things that are really cool that you should look at. There are the streams APIs, there's the date and time API. If you're doing mobile or if you're doing like embedded devices, you might want to look at the new compact profile. So take a look at Java 8, not just the language features. It has a lot of cool stuff that you will want to use. Then we will, of course, see how these things work in Eclipse. So you will see what Eclipse does for you, what you don't have to do by yourself. And I will do that in combination. So we will not just have theory and then we go into Eclipse. So we'll go back and forth. And then if we have enough time at the end, we will look behind the scenes. So what is the team, what did the team go through, and how did we implement stuff there? So if you have any questions during the session, just raise your hand. I can take the questions. You don't have to wait until the end. So the new Java language features come in two different ways into Java 8. So the first one are the ones that are known, like the JSRs. The JSRs are the Java specification requests, which is the old and known way where things are proposed. There is an expert group, and then people vote on it, and then it comes into it. And these are the JSR 335, the Lambda expression. And we will later see that most people just talk about Lambda, but I think there are much more interesting, or at least as interesting things that come into the language with this JSR. Then you have the JSR 308, which allows you to annotate types. We will see a bit later what you can do with that. Then the other thing are the JEPs. Who does not know what a JEP is? Okay. so the JEP is you can say this is the new way. This is connected to OpenJDK, where the developers make proposals. So this is the Java enhancement proposal. Maybe some of you know the diamond or the multi-catch or the switch on string that was introduced in Java 7. So these are all small language changes that got introduced over the JEP process. And in the end, the developers or the company needs to propose those, and then they get into the language itself. So here we have two of them. One is the method parameter reflection, and the other is the repeating annotation. I think I will quickly explain what those are because they are really small, and I'm not sure we have time to look further into these in detail here. So the parameter reflection is really what it allows you is to tell the compiler to store parameter information in the class file, and it's explicitly called parameter information. But in Java 8, it only stores the parameter names. That's the only thing that it really does. It stores the name of the method parameters in your class file. And then there's a new class, Java long parameter, and this allows you to retrieve those parameter names, and it also allows you to retrieve things about parameters that are already stored in the class file before. And you have to enable that feature by telling the compiler that it has to store it. Otherwise, there is no change compared to Java 7 with your class files. Now, repeating annotations, that is really, really a small feature. What it allows you to do is you can use the same annotation type with different arguments on the same element. Before, that was not possible. So that's really a small enhancement. But still, some might find it useful. So we're already in the JSR 335 in the Lambda. And as I said before, I think there are other things that are worth mentioning, and here I start with two new types of methods that are available in Java 8. So the first one, we'll talk a bit more in detail because it's the more interesting one, is the default methods. They were under the name deferred methods or virtual methods known before. And the other one is the static interface methods. Static interface methods allow you to add, let's say, utility methods to your interfaces. So in previous version of Java, you had your interface framework, and then if you wanted to provide helper methods, you had to create a class and put the methods there. And now you can attach them to the interface, and this is really convenient. One important thing you need to be aware of is that it's more strict than when you have static methods on classes. You cannot call them on a subclass. You really have to use the exact qualified name to actually call the method. So default methods, what is the intention? So previously, when you would only care about this if you have to maintain API. If you have to maintain API, you usually have either you have a framework that consists of classes, abstract classes, or you're more focused on interfaces. And if your framework consists of interfaces and you want to extend it in the next version, then you're locked in, because if you add a new method, you will break your client. We will see this later in the code example. So with default methods, what it allows you to do is you can add methods to an interface without breaking the client. So how is that done? So there is only one way to do it. It is you provide the implementation along with the method. So you have a method which is then also providing the implementation of that method. So my question for you, why is it part of JSR 335? So why is this part of this specification? Does anyone know? No? Okay, so of course, if you introduce something big like lambdas and you have this new construct, you want to be able to also rework your frameworks. For example, a good thing is the collection framework. There you have a lot of interfaces, and you have lots of opportunities where you could use lambdas. For example, the compare methods, where you compare the elements of the collections. And with this, they can use the existing collection interfaces and add new methods where it can take a lambda construct, or they can also add, for example, the static interface methods. So who thinks we now have multiple inheritance? Hands in the air. Okay, unsure. 3. Who thinks there is no multiple inheritance now? Okay, that's a tie. So yes, you will have multiple inheritance. You can now inherit implementations from different branches of your inheritance tree. What the compiler actually forbids, as soon as it detects the same method twice, even if it comes from the same interface, super interface, it will throw an error. And we will see later in the code how you can actually fix that, but you should always avoid that. This is bad design and it will not work in the future. So before I start, who does not know how to set up the Java 8 development on Eclipse? Okay, you can come to me afterwards. So if you know how to set it up, just one little thing. Often what happens is your colleague sends you a code snippet, you paste the code snippet into a project, and then what you get is you get errors. Unfortunately, I just pasted it into a Java 7 or older project, and here JDT helps you. So you see there is an illegal modifier, or here I have default methods, so I can just go and change the project compliance to 1.8. And it changes the compliance, it adds the JRE if you have a JRE 8, and everything works again. So this is just the first thing that helps you to go from Java 7 to Java 8. So now let's look at how a default method looks like. So here you see a default method called subtract. it has an implementation, and if I would have added just this method here, let me do it this way. If I would have added just the method in my framework, like this, you see there are lots of errors in my client code. So in the past, this was not possible. There was no way to use the interface. You had to introduce an abstract class, or you had to introduce an extension interface to fix that. So now, I think, okay, let's use default methods. So I just go, and I make an implementation. And what I still have is an error. So why do I have an error? So now you can use JDT again. JDT will tell you, okay, this doesn't belong here. You cannot add an abstract method with a body. So JDT gives you 3 choices to fix the problem. So in JDT, you can declare it default. That's what I want to do now. You can also declare it static, so it becomes a static method in your interface. Or I can remove the body again, which obviously I don't want to do now. So this is how JDT helps you with defining the default methods. And here, just as an example, you see a static interface method. This is really just the same as you have with static methods before. Yes?
What happens now if I have I bigger 2 supplying some string already? Will I get it out of I?
I will show that. Yeah. It's even worse than that, so you'll see. So here, just another feature, if you have control or if you have the outline, you will see there is a decorator that tells you it's a default method or a static interface method. So you can throw that away. So now let's go to last question. So last question was, what happens if I have it twice? So I want to build a supercalculator here. So currently it's just a scientific calculator, but let me make it also a binary calculator. And it doesn't work. And here you see what the compiler tells you. You have a duplicate implementation. It doesn't matter whether it comes from 2 interfaces or from the same interface, the compiler will give you an error.
What if the other interface would not have implementation? Would that work?
Yes, it's just about the implementation. Only if you have 2 different implementations that contradict, you will get the error. That's the point.
So we could, in Eclipse, we could use our smart listener 1, 2, 3, 4. We could actually upload 1, and the 3 would still not have defined.
Yes. So there is one thing that JDT still can't do, we're working on that, is there's no quick fix to actually fix the problem. So you have to know that you have to provide the implementation here. So I can just go. And then here, you see there's a new construct in Java 8, it's called super. And you can now call the concrete implementation of your choice here in that code. You don't have to do that, you can also return 0 or whatever you like, but you have the choice to actually use the implementations. You can use the implementations, you can also use both implementations or all implementations that you inherit in the same method here. Okay, any questions to default methods? So let's move a little bit back. And now let's go to the Lambda expressions itself. So Lambda expressions, I think at least the older guys here in the audience, they have used it maybe when they programmed in Smalltalk. They were named closures, and they were actually introduced in the theory at 1930 or something. So it's really not something new. It just took quite a while until it made its path into the Java language itself. It was, even in Java 5, they had something that wanted to go in, but then there was a lot of discussions at that point. So what is a lambda? Lambda is nothing else as a function and capture state. And this is then passed as data, so that you have the possibility to pass that on to some other function as a data object. And what does it bring you, and what was the intention? The intention was really that, like Lars mentioned, all these listeners, that you can get rid of all these anonymous classes in your code. And I will have to disappoint you later about that, so you will see it's not that fancy as you might think. So there are some constraints here. Now, the scope. Again, with Lambda, I cannot explain why this went through the spec, but with Lambda, you actually have a new kind of scope. Before, when you had your anonymous classes, you had your own scope. Everything was restricted to that scope, so you could redefine local variables in that scope. With Lambdas, you can no longer do that. With Lambdas, you inherit the local variables from the outer scope. So you cannot redeclare a variable that you already declared in the outer scope. So this is new with Java 8. And the other thing is when capturing the outer state, what it captures are those local variables that are declared final. So you have the effective declaration of final. But again, the compiler in Java 8 has to do more work for you guys. So the compiler goes in and it detects which local variables are final, even if they're not declared final. And so you can just use them in the Lambda itself. So you don't have to declare them final. And you can do the same with anonymous types. So you no longer, for example, have to declare method parameters final just because you later use them in a listener below. So this is also something which is new in Java 8. So the other thing that you have to be aware of, since it's called Lambda expression, a Lambda can appear everywhere in the code where you have an expression. So this made it very, very hard for my team, for the compiler builders, to actually react on that change, because it's really a drastic change, because you had new operators appearing at the place where you have expressions. And the other thing you also have to be aware is that a Lambda needs a target type. So whenever you want to use a Lambda, there needs to be a target type. For example, an assignment, so it gets the type of the left side, or you have a method call, or you have a cast. So the type is required, otherwise there will be a compile error. Okay, so now it's time for some demo. So here, this is the traditional code that you're used to see everywhere. You have a method that takes some interface. Here it's the iCalculator that we just looked at before. And then what you have to do is you have to create an anonymous class if you don't have a type already for that. So this is the usual listener code, for example, that you know from your own code. And just to show you, this is so here, this is just a simple method that we will use later on in the code as well. So nothing spectacular. So now how does that look like with Lambdas? This is the same code with Lambda. So you have a one-liner only. And if you read that, you will probably not be able to judge directly from reading what it should do if I hadn't shown you the code before. So what we do in JDT, we have a hover that tells you, okay, this is the implementation of iCalculator add. And you can also jump to it here, and then you see this is really the implementation of it. Now, let's look at some more examples here. So here, you have the same thing again on this line, but the difference is you have the types for the parameters as well. So this is just sugar for normal people that they can understand better the code. And it's also something that the JDT gives you. If you prefer the short writing, that's fine. If someone comes and prefers the longer one, the compiler can infer the type for you, and then it puts the type there. So that's also something you can do. Then here, as I said before, you need the type. Here, the type comes from the method invocation. Here, it comes from the cast. Here, it comes from the left side. Now, here, you actually saw before that calculate returns something. So if you have a Lambda, there is an implicit return. So you don't have to write the return here. It just uses the return value of the method. Now here you see a second example. Here you see there is a code block. So you have the choice between having an expression or having a code block. And of course, you can also convert that with JDT back to the shorter variant, or if you prefer, it can also move it to a block again. So you have the choice. If you don't like the code, you can move around with the features, with the quick assist from JDT. Now, obviously, what you will ask me is those are not the interesting cases. So the interesting case really is this one, right? So you have code like this, and what you really want to do is you want the quick fix or the quick assist to convert the code. And since you don't want to do that for everything that you have in your whole project, we have a cleanup. So you can execute the cleanup here. Here is the functional interface instance cleanup, and you convert from one to the other. So if you have a new kid in your team that just writes lambdas and you don't like it at all, you can go over his code and move it back to the old style. So you're free to do that, and you can also do it the other way around. So it's really, really up to you. Then, now I think you understood lambdas, right? So can you tell me what this does? Yeah? No? Okay, so here again, if you really know all the libraries and all the interfaces and you know what they're doing, you can probably guess what it's doing, right? But if you don't know, the only thing you can do is you hover here and you will see, okay, this is the method call on callable, which returns a runnable. So I will have to implement a runnable. So the next thing I have to see, what do we have here? So here, of course, we have the runnable, which needs the run method. And then on the right-hand side, we have the implementation of the run method. And that actually runs that code. So now, unfortunately, we are at the bad side of the news. Those that paid attention before, when we went here, you maybe noticed this functional interface. So this is an optional annotation to annotate functional interfaces. And functional interfaces is the only thing that are allowed to be used together with a Lambda. So a functional interface, unfortunately, only allows one abstract method. If you have 2 or 3 or 4, you're doomed. So most of the listeners, you probably know, they have more, so this will be useless for you. That's the bad news. Why do we have an annotation here? There are 2 reasons for it. First of all, for you, if you read it, and then if you change your code, for example, you add a new method. Let's say you don't care about your clients, you go here, and you add a second method. Then the compiler can actually complain that you made a mistake. If you don't have the annotation, the compiler will not complain, but your clients that use Lambda on this functional interface, they will be broken. Now, there's still a little bit of good news. What you can have in your functional interfaces are the new static methods, so you can add as many helper methods as you want to your interface. You can also have code or methods from object like hash and equals. That doesn't hurt, so only abstract methods are restricted to exactly one instance that you can use there. So maybe quickly, for those of you who are addicts of the formatter or who change all the details so that it looks different in your project, we here also have some new options. So you can specify whether you want the space or you don't want the space. So those are really details, but those are the details that some people try the loudest of. And we have them here. And the other one, I think, is here, the braces. So you can specify whether you want the lambdas on the same line, on the next line, and so on. So these are just, this is really a small feature, but might be in favor. Some people might like it. And now to another feature that comes with JSR 335, which most people really don't know. I think it's even cooler sometimes to use than Lambda. It's method references. So method references are really more or less the same than Lambdas. The only difference is they don't provide the implementation. They refer to a method that has the implementation. So here you see this is the method reference separator, and this is a reference to the method. This implements the comparator compare method. So comparator is now a functional interface in Java 8, so you can use it here. And here, what I do is I pass on a reference to integer divide. So you no longer have to actually inline code. You no longer have to implement the code or copy the code. You can just reference methods from some other libraries. And I think this is really cool, and it's a form which is readable. It's not something like the lambdas where you can really end up in code that is totally unreadable. And here we have a hidden feature. So just many of you might not know that, but if you do a search, sometimes you have really the need to restrict your results to some special things. So here there's an advanced feature where you can restrict the results, for example, to this references or super references, and here you can also restrict it to method references. So this is the new feature, but I also encourage you to use the other things if you really want to do a really fine-grained search. Okay, so let's now jump to the JSR 308, just quickly. Annotations on Java types. If you look at that code and you never used annotations, you will probably tell me that you could do that before, because you see the annotation before the type and you might think it's just there. Also on the second example. But the fact is, those annotations in Java 7, they are on the declaration. So they're on the field declaration or the variable declaration, and they're not on the type itself. And in Java 8, what you can do is you can really annotate the type parameters and the type references with annotations. And why is this extremely useful? Because it allows you to add constraints to your framework. So the most probably widely known is the null annotations from Stefan Hermann that you can use to annotate your code, whether it's null, non-null, or undefined. And then we can do much more interesting analysis on your code. And only with the annotations on types, it's possible to annotate the parameters, for example, in methods. Before, it was, I would say it was not very useful, but with that, the null annotation analysis becomes very handy, and I think it will get much wider adoption than it did before. So let me quickly look behind the scenes. So let me start with the team. So this is the team a year ago, which has built the JDT support for Java 8. You see the people on the right are mostly IBMers on my team, and the others, like Stefan Hermann, he contributed a lot of his free time to the project, so he is also the guy behind the null annotations framework. Then we had lots of help from Andy Clement and Jasper Miller. So these guys really helped a lot, and it was a community effort, not just like an IBM effort, and we also had lots of people in the community testing it, reporting bugs, and that was really helpful. So I want to say a word about implementing the specs. It's funny when I go to conferences, still a lot of people, they don't know that JDT or Eclipse ships with its own compiler. So we have a complete implementation of the compiler for the specifications that are needed to actually comply with Java 8. And here, since it was really complicated, my team participated in the JSRs, and we always discuss things with them, but the main problem was, at the beginning, there was no JSR. And then what happened is the OpenJDK community, they started to implement things, and they started to craft the spec, let's say, along the code and not the other way around. And for Eclipse, we are only allowed to look at the code. We cannot reverse engineer Java. We cannot look at the OpenJDK code. That's not allowed for us. So we had quite a lot of problems last summer when the spec was not complete, and really had to have a lot of discussions with the JSR participants how we want to go forward. So this was really a lot of work. And the other thing what now happens, since Java 8 is out in March, we get bugs that our compiler is not working. Oracle gets bugs that their compiler is not working. And then we have to see and discuss, is it our bug, is it their bug, is it the spec bug? So it's really interesting and also requires quite a lot of work to do that stuff. And I think in the end we have quite a good specification, and it really helped that we have 2 compiler implementations. If we only had one, then the result would not be as good as what you now have, may it be from the Eclipse compiler or also from if you use Java. Java also could fix a lot of bugs because we participated in this effort, so that was really great. And last but not least, we got a lot of complaints that we are not shipping releases on a weekly basis with the current state of the Java 8 support. And I just want to explain here why this is the case. So this is a specification, and this comes with a license from Oracle. And this license doesn't allow to actually develop an unfinished version of the compiler in a product or in a build that is sort of consumed by the community. So that's why we had to, when we had something really usable, we could provide a feature patch on our own servers that you could download, but we were not allowed to have it included in a milestone build, for example. And we are still working together with Oracle to make that easier for Java 9. So hopefully we can do that at some point. Okay, at the end, I'd like to show you just some numbers. You can read them by your own, so you see what we all achieved here. And if you have any questions now, I'm ready to take them. Yes? So the question is, does the Java 8 also allow partial functions? Yeah. No, you don't have partial functions there. You just have the implementation. So what it does, it takes the type, then it looks what method is there only a single method, and then what you have is the implementation for that single method. Yeah. It's different. It might work if you don't have Java 8 constructs, right? But if you have Java 8 constructs, it will not work. It's not compiling code in a Java 7 format in that sense, if you use the new features. But if you use the Eclipse or the Java, you can specify the target. So if you really have, you can use the Java 8 compiler to produce 1.4 code if you want, but you cannot use the features that are above 1.4. Any other question? Okay, then thanks for your time and happy coding in Java 8.